In this video, I'm going to assume you're already familiar with Argand diagrams, and we're going to look at the different loci you might be asked to sketch related to these. In the A-level further maths course, there's three types of loci that you'll be expected to be able to sketch. One is looking at when the modulus of a complex number is fixed. One is looking when the modulus of two complex numbers are equal, and one is related to arguments. So we're going to go through each three separately and then look how we can combine them. The simplest of the three is probably when we're given just the modulus of a complex number is equal to some constant. So if you're told the modulus of z is equal to 4, this is simply saying, well, the distance from the origin is equal to 4, and on your Argand diagram, that's simply going to look like a circle around the origin with radius 4. So these intercepts here would be 4, and it would be fine just to do an arrow there. As long as your intention's clear, then you're going to be good. The way this can be complicated is rather than just being given the modulus of z, if you're given something like the modulus of z subtract 3 plus 2i equals, let's say we've got equal 2 now. So it's still going to be a circle, and in this case the radius is now going to be 2 because we're told it's equal to 2, but the centre's not going to be at the origin because we're now given this situation where we're doing z subtract 3 plus 2i. We're saying the distance from 3 plus 2i, so our centre of our circle is now instead going to be at the point 3 plus 2i, so make sure it's clearly labelled on there. And then when it comes to sketching your circle, in this case, when you get to the radius of 2, there's one thing that you should be cautious about, because this distance here is exactly 2. So when you're drawing your circle, you'll want to make sure it just grazes there. Otherwise, you could just label clearly, make sure it's obvious on your diagram, clearly labeled the radius is 2, and you'll be fine. Now, I gave you brackets in that case. The way I could have complicated this question a little bit further is I could have presented the exact same thing to you as z subtract 3 subtract 2i is equal to 2. And now the centre's not as obvious to see. It's definitely 3 plus 2i isn't staring at you in the same way as you get that. So whenever you get a question like this, as your very first step, rewrite it with z subtract and put brackets around the whole thing. But you need to be getting it in z subtract form in order for the centre of your circle to be obvious. So that's situation number 1. And that's always going to give us a circle. Situation number 2 is still involving moduluses, but we're going to have a modulus on either side of our equation here. So let's imagine instead we've got modulus z subtract 3 plus 2i is equal to the modulus of z subtract, and I'm going to be nice here, I'm going to put brackets in on both sides, 2 subtract I. So this, just to be clear what we're being asked for here, this left-hand side is describing the distance from the point 3 plus 2i, and the right-hand side is describing the distance from the point 2 subtract I. So if we get an Argand diagram here, just so we can think what's going on. So we can have our real axes and our imaginary axes, and we've got 2 points that we're interested in. We've got 3 plus 2i, so we'll get our labelled 3 and 2. And then we've got another point, 2 subtract I, so 2 across and just 1 down in this situation. So that's -1, and that's 2. If we're saying that the distances from those 2 points are equal, this is really a way of saying we're looking for the perpendicular bisector between these 2 points. So when it comes to drawing this, most of the time you're not going to be able to do this really accurately, but just make it as obvious as you can what you're trying to do. So we're trying to draw a line that cuts perfectly through those 2 numbers. And if you want to make it really clear, I suppose you could do this and draw a right angle triangle there. But I'd probably even maybe just label and say you're doing the perpendicular bisector, because it'll guarantee you're making it clear to the examiner exactly what you're attempting, and you're not risking something slightly weird about your line losing you any method marks at the very least there. Obviously, I'm not working with a ruler here. Do it properly with a ruler, make it as clear as you can what you're attempting to do there. So on those, same as before, make sure you've got them in the form z subtract, and then you know which 2 points you're looking at, and then you're just going to draw a line as a perpendicular bisector between the two lines you've been given there. So that's the second situation where we've got a modulus on either side. The situation we haven't looked at so far is if we're looking at the arguments of complex numbers instead. So what if we're told that we've got the argument of, and I'm going to stick with the number we've been working with, z subtract 3 plus 2i, and I'm going to tell you the argument is equal to 3 pi over 4. So what are we going to do here? Well, let's start. Get our Argand diagram out. So we've got something to work with. Get our point 3 plus 2i labelled. Now, if we're looking for points where the argument is 3 pi over 4, we're measuring it from this point. So I'm about to draw, I wouldn't draw this line in orange just yet, but that line in orange, any point on that line would have argument 0, because we're not measured from the point 3 plus 2i. We're not rotating through any angle there. We're looking for the points where we're rotating through an angle of 3 pi over 4. Well, that's 135 degrees. So that's going to be going off in this direction here. There's three things I'd recommend you adding to make your intention really clear here. Firstly, label your angle. Make clear it's 3 pi over 4 you're looking at. Secondly, put an arrow, which I've attempted to do there, on the end of your line to show your line will continue going in that direction. Note, it's not going in both directions. It would be wrong to have your line also going infinitely down and to the right, because if you did, the line I'm about to add just briefly here, oh sorry, I didn't mean to get rid of that, my axis there. If we tried drawing an extra line down here, that line would have angle argument negative pi over 4, so we don't want that one. We only want it going up and to the left. And finally, and this is a subtle point, and some math schemes won't pick up on this, but it's something you should be careful with. I would do an open circle at the point 3 plus 2i, because that point itself shouldn't be counted as part of our line. If we look at the argument of that point from 3 plus 2i, it doesn't make sense. We're looking at the argument of the exact point. So we need to have moved off that point. So I'm just doing an open circle to show we're not including that point itself. So you don't really need the orange line, but you want some way of signifying that you've twisted around an angle of 3 pi over 4, but make clear that it's what I've labelled as the blue line is your answer. It's fine if you just point to it and say, this is the answer, and make clear the other line is just for reference. But intention, you will get markers being generous as long as your intention is clear, so just make sure you're making as clear as possible what you're trying to do here. Okay, let's look at one situation where we're going to combine a few of these ideas, because you'll get some questions like that, but you'll get some questions that throw a few things at you. So I'm going to ask is for the loci, the set of points in the Argand diagram that both satisfy this first inequality, which is 1 is strictly less than the modulus of z subtract 5 plus 4i is less than or equal to 3. And I also want us to have that the argument of z, I'm just going to go for z in this case, is greater than or equal to negative pi over 4. These are two things we want to deal with. First thing, before I even draw an Argand diagram here, is I want to rewrite something about this first one. And what I want to rewrite is, I've given you this question without brackets. Let's rewrite it, put in brackets in. So we can rewrite this as mod z subtract brackets 5 subtract 4i is less than or equal to 3. Now let's get our Argand diagram and go through step by step to consider what we need to deal with here. If I asked you for the modulus of z subtract 5 subtract 4i was equal to 3, we should say that's a circle centered at 5 subtract 4i. So let's go, let's get our point. 5 subtract 4i is going to be somewhere around here in our Argand diagram. And modulus of 3, we're not going to be hitting either of the axes here. That's important. I'm going to get something like this. And I'm going to make sure I'm clearly labeling on my picture that our radius is 3. So there's no doubt to the examiner what I'm trying to do there. Now, if we want the modulus to be less than or equal to 3, we're saying the distance from that point is less than or equal to 3, we're going to be inside that circle. But let's start to deal with the other stuff first before we finish that. We're also told we want the modulus to be greater than 1. I want to do another circle with radius 1, but because we're given a strict inequality here, I'm going to do a dashed line to signify that. So I'm going to do another circle with a dashed line with a radius of 1. I might actually struggle to label this clearly on there, so I'll probably just point at this and say this is radius 1, because then it's obvious what I'm attempting. And if this was all we were asked for, I'd be looking at the region between those two circles. There's one extra thing we've got to worry about here, which is we're looking at this argument. We're told the argument of z is greater than or equal to negative pi over 4. Because it's not z subtract anything, we could write as z subtract 0 plus 0i, but that would be overkill. We're just measuring from the origin here. So we're going to put on the line, starting at the origin, I'm going to do an open circle there, going at an angle of pi over 4 below the real axes, because we're looking at the argument being negative pi over 4. Now, it's worth considering where this line is going to come with relation to our circles, because I've not drawn the perfect scale here. It's not going to be amazing. If I'm going at an angle of pi over 4 below, or 45 degrees below, that means when the real part's the real part's 5, the imaginary part will be negative 5. So I actually just want to be hitting the very bottom of the circle. I've not done it very well there. In fact, I'm going to try doing that again. In an ideal world, you'll be doing this with a ruler. I'm doing the best I can here on my iPad. So we've got this. I'm going to do an arrow showing my lines continuing their way, and I'm also going to label this angle as pi over 4, so it's obvious what I'm attempting to do there. Okay, so which part are we interested in? In relation to the circles we've got, we want to be between the inner circle and the outer circles, because we want our radii to be between this. And if our argument's greater than or equal to negative pi over 4, then we don't want to rotate any more than pi over 4 around. We're going to want to be above that line as such if we're rotating anti-clockwise from there. And the region we're going to want is this region I'm shading here. So that's the region we want. There's not a clear convention nowadays with whether you should shade the region you want or don't want. Sometimes the question will tell you, other times it will ask you just to label the region. So if you choose to shade it, do that, and then just have a clear label saying this region, brackets, shaded region, something that makes it clear to the examiner what you're intending there. But don't assume that shading by itself will be sufficient. Just have a couple of words to explain now that's the region you're looking at. Okay, thank you very much.